Hello, hello, hello guys. Today is my topic about graph of a tree matrix. I'm MD Shakir Hussain. My room is 21951A12444. I'm from ITA section. IARE. Introduction. The matrix tree theory is a formula for the number of spanning trees of a graph in the terms of the determination of a certain matrix. We begin with the necessary graph theory background. A GBF fine graph allowing multiple edges but not loops. Properties. What are the properties of it? This tree? A connected graph with number of cycles. Forest, a graph with no cycle. Stars are trees. Star a tree consisting of vertices adjacent to all other definition of trees. Here, the The following statements are equivalent for a loop-free undirected graph. G is equals to V comma E. G is a graph is a tree. Graph G is a graph. Graph is constructed by removal of any edge from the graph disconnected G into two subgraphs that are trees. Graph contain no cycle and V is equals to E plus 1. G is connected and V is equals to E plus 1. G connected no cycle and if A comma B equal to V and G is frequent. Loop connected. Loop could be allotted but there turns out to be complementary event. We say that G is connected if there exit a wall between any two vertices of G. The cycle is a closed wall with no repeated vertices or edge except for the first and last vertex. A tree is connected graph with the no cycle. In particular, a tree cannot have multiple edges since a double edge is equivalent to a cycle of length 2. Matrix tree theory. We'll now study the result matrix tree theory, called Cauchy-Binet theory. It's also called Cauchy-Binet theory, and it used for proof the famous theory called matrix tree theory in Kirchhoff 1847. To do so, note that for an M into N matrix A and S, open column 1 comma 2 are empty. Here took this matrix. The notation A as S into T denotes the submatrix A. It determined by the rows and that correspond to the element of S and the columns that correspond to the element of T. For example, if in graph theory a tree is an undirected, connected and cyclic graph, tree provide many useful applications as simple as family tree to as complex as tree in data structure of computers science. A tree, a leaf, a tree is a vertex of degree 1 or any vertex having no students is called a leaf. 1 comma and 2 comma 3 comma 5. Then a is equals to 2 and 1 comma 4. We know use the above notation to prove a result related to the edge incidence matrix of a connected graph. Let X be a connected graph on n vertices and m edges. Also let Q be its edge incidence matrix. If T is 1 comma 2 to m with T is equals to n minus 1, then delta is equals to 1 comma 2 n minus 1 it will come. The if any only if the submatrix Y or X is connected, consisting of edge that correspond only to the element of T forms a spanning tree of x. Proof. Note that x is a connected graph and hence n minus 1. Thus, there always exists subset t of 1 to 1 comma 2 comma up to m with t is equals to n minus 1. Now suppose that y is not a tree in the condition that y has n vertices and n minus 1 edges. This means that y is disconnected. Consider a component y that does not contain the vertex n. Note that one can the variable then vertices and edge of x and q. The tree is an uncyclical connected graph. An adjacently mapping of the graph is a 0, comma 1 mapped in which the entry is if there is an edge. If there is an edge, matrix of a graph is if the entry is there is an edge between and there. See, this is a particle graph x and y which I had did before. See, we should have to take the 0 and here 1 comma 1 comma 1 and like this 1 2 3 4 5 6. You have to take 6 rows and 6 columns, so it will come 0 a of b and a of b transpose t. Check whether the graph is tree or not. How we can check a graph is tree or not? Write a function that returns true if a given undirected graph is tree and false otherwise. For example, the following graph is a tree. You have to do this. An undirected graph is a tree. It has following properties. There is no cycle. The graph is connected. For an undirected graph, we can either use BFS or DFS to detect above two properties. How to detect cyclic is undirected graph. We can either use BFS or DFS. For every visited vertex V, there is an adjacent U such that U is already visited and U is not part of it. Then there is a cycle in graph. If we don't find such an adjacent from any vertex, we say that there is no cycle. Theory 1. The number of spanning trees is a graph G is given delta. For any I, for the first proof, we need the following fact: L is equals to A and R n into n and take I E double I to be the matrix. Then we get delta A plus E I equals to delta A plus delta Aj. Now, how do you prove the graph is a tree? By an indirect graph is a tree if there is exactly one simple path between each pair of vertices. Proof: if we have a graph T which is a tree, then it must be connected with no cycles. Now suppose we have a graph G where there exactly one side path between vertices. So this can also implement that there is a graph is it tree or not. So this will goes on a cycle is global board with no relation of edges except for the first term and last term. A tree is connected graph. See this in this graph you can see that one is connected to 0 and 2 is also connected to 0. By this, then 3 is also connected to 4 and 5. This function returns as this is like the 0 and a comma we are a b data of 0. For that purpose, we are using graphs. We can either use PFS or DFS. Best resolution for every visitor vertices a V if there is an adjacent U such that U is already visited and U is not part of V. Then there is a cyclic graph. If there is a cycle, if we don't find such an adjacent from any vertices, we says that there is no cycle. If we find them, then we can say that is a cyclic graph. So there is a adjacent to formulas. Let me see next slide. An undirected graph is a tree if there is an exactly one simple path between each pair of vertices. Undirected graph is a tree like this. Undirected graph experience. It's undirected graph of the trees, which is exactly simple path. Have exactly simple path of between each pair. If we have a graph which is a tree, they must be connected within no side. Now suppose we have a graph G where there is exactly one simple path between vertices. Thank, thank you friends for watching my video. Please like, share and subscribe.